Okay, today we are going to add a little flavor to it, to factoring. Before we factored binomials. Binomials have two terms, and so the difference between a binomial and this is this has three terms, so we call that a trinomial. Trinomial consists of three terms. But what you do to factor a binomial is going to be the same thing you do to factor a trinomial. Take each term, 5n to the fifth, 8n to the fourth, negative 8n to the third, and you want to do the prime factorization of it. We're looking for the greatest common factor. That's nice and easy. 5 is a prime number. And then n to the fifth, when we do that, we just break it down into a multiplication. So we have n times n times n times n times n. 8 becomes 2 times 2 times 2 times n times n times n times n. Negative 8, we need to remember to factor out that negative 1. 8 is 2 times 2, and then n to the third looks like this. So we want to circle what they have in common. They have an n in common. They have a second n in common. They have a third n in common. Now these two have an n, but notice that there's no more n's in negative 8n to the third. So we cannot take a fourth n, even though these two have an n, we can't do that. So all three must have this factor in common. Now here's an interesting thing is they have nothing else in common. They have no constants. These don't have a 5, and even though these two have 2's, this doesn't have a 2. So that is our GCF. Our GCF can consist of just variables. So my GCF is going to be n to the third. Now what's left after we take n to the third away? We're left with 5n squared. So that's what's left from this first term. And then when we take an n cubed, when we take an n cubed from our second term, we're left with 8n. And that's a positive 8n because if you look, 2 times 2 times 2 times n is positive 8. And then our third term, I didn't mean to do it in that color. In our third term, we have negative 8. And it's negative because we have a negative 1. So that's how we factor trinomials, identical to what we were doing before. So the beginning of each step is going to be doing the prime factorization. That's 2 times 3 times n times n times n. We have negative 1 times 2 times 3 times 3 times r times r times r. We have negative 1 times 2 times 3. They have a 3 in common. R, I called them n's, but let's make them r's real nice and quick. You probably saw that and said, why is he making those n's? Those should be r's. And that's all they have in common. Yes, these two have negatives, but this doesn't have a negative. Yes, these two have r's, but this doesn't have an r. So we can only take out a positive 3. So my GCF is going to be positive 3. That goes on the outside of the parentheses. And I'm left with 2r to the fourth. I'm left with negative 2, negative 6, negative 6r to the third. And I'm left with negative 2 minus 2. Good. So 4b to the seventh, that's a lot of b's. 3b squared, 7b. 2 times 2, 1, 3, 4, 5, 6, 7, and 7b. They're going to have a b in common. And that's it. That's all they have. So We're going to factor out a b, and we're left with 4b to the 6th. We're left with 3b, and we're left with 7. 10x squared, 5x, negative 25. 2 times 5 times x, 5 times x, and negative 1 times 5 times 5. So they have a 5 in common, and that's it. Factor out of 5, you're left with 2x squared. You're left with x, and you're left with negative 5. (15n to the third), negative 3n squared, 21n. That's 3 times 5 times n times n times n. That's negative 1 times 3 times n. And that is 3 times 7 times n. So we have a positive, well, I'll do it in yellow, positive 3. And now we have a secondary number. So my GCF is going to equal the 3 times the n, or 3n. So we're going to factor out a 3n. That leaves me with 5n squared. That leaves me with negative n. And that leaves me with 7. (12n to the third), 8n squared, negative 24n. 2 times 2 times 3 times n times n times n. 2 times 2 times 2 times n times n. Negative 1 times 2 times 2 times 2 times 3 times n. They have an n in common. They don't have a 3, they have a 2 in common. And that's it. So my GCF is 2n. Factor out that 2n. And we get 6n squared plus 4n minus 12. Nice. And that's, we don't have to do that. We can start getting good at this. 7a to the third, 28a squared, 28a. 7 times a times a times a. That's 2 times 2 times 7 times a times a. And that's 2 times 2 times 7 times a. They have an a in common, and they have a 7 in common. So my GCF is 7a. That leaves me with a squared plus 4a plus 4. Now we should be going real good. So 18x to the 6th, negative 12x to the 4th, 36x squared. 2 times 3 times 3 times 1. Did A so low. 1, 2, 3, 4, 5, 6. Negative 1 times 2 times 2 times 3, 2, 3, 4. 2 times 2 times 3 times 3 times x times x. All right, they're going to have an x in common. They're going to have a second x in common. They have a 3 in common. And they have a 2 in common. So my GCF is 2 times 3 times x, or 6x squared. Nice. 6x squared. We're left with 3x to the 4th minus 2x to the 2nd plus 6 and that's it. So can we look at this and see what our greatest common factor is? So we look at those coefficients, 5, negative 40, positive 30. So I always look at my smallest factor, 5. Can 5 go into the other ones? Yes, so we can factor out a 5. Now we look at x to the 5th, x to the 3rd, x to the 2nd. What's the most that I can take from each of those? I can take, you go look at your lowest one again, x to the 2nd, I can take an x to the 2nd from there and there, so 5x to the 2nd. That leaves me with x to the 3rd minus 8x plus 6. 5 goes into 5 once. X, if you take 2x to the 2nd from x to the 5th, you get x to the 3rd. 5 goes into negative 40, negative 8 times. X to the 2nd from x to the 3rd leaves me with 1 left over. 5 goes into 30 6 times. And x to the 2nd, if you take 2x's from 2x's, you're left with no x's left. 6, 30, 42, 6 goes into each of those, and I can take out an n. So that leaves me with n squared plus 5n minus 7. That's how fast you could do those. I would advise you to do the prime factorization until you get really good. Come and see me.